Hey everybody, Mrs. Bodechon here. So we're going to look at 3A. It says, I can plan and carry out investigations to generate evidence supporting the claim that mass is conserved during a chemical reaction, types of reactions limited to synthesis, decomposition, single replacement, and double replacement. So on your sheet, it's asking you, what is the law of conservation of mass? What that states is right here in red. Mass cannot be created or destroyed, only transformed. This should look familiar to you. It should look like the law of conservation of energy, except we're switching out the word energy for mass. It can also be stated as matter instead of mass. It's all going to be underneath the same law, you guys. So it's the same principle there. So you have this scenario. It says, plan an investigation to prove the law of conservation of mass is true for a pile of wood that has been burnt. So if you start out with a pile of wood, like if you're going to make a campfire, and then when it's done, it looks something like this: a pile of ash, maybe a couple pieces of wood left, but clearly it's not as big as it once was, right? So there's two kinds of systems, if you remember. There's an open system and a closed system. If you were to do this out in the wilderness, that would be considered an open system, because when this burns, all of the ash and smoke and soot, everything will end up going into the air and it can blow away, and that's an open system. We're losing energy, or we're transforming energy outward, right? It's not being contained. So if we put this into a closed system, say like a really big dome, where there's still enough air for oxygen to let the fire burn, but where we can also collect that ash and the smoke and everything that's happening to this fire, then we can prove this law. So we can take the mass of all the components before the fire, the wood and everything, right? And then we can take the mass of everything afterwards, which means we'll have to collect it all. And that's a little bit difficult, but you can do it. So you would have to get all the ash, all the soot, all of the logs and everything. And if you take the mass of it before and after, it should equal the same mass, right? And that would prove the law. But just remember that we do transform energy into other things as well, okay? So there's a transformation of energy happening, but there's a conservation of mass. So the mass is the same before and after, no matter what. If you're doing a closed system, you'll be able to gather all of that mass and see it as truth, okay? All right, so now you're giving all of these different types of reactions, and it says, hey, put them where they go. Well, you haven't learned this yet, so let's learn this. So you have 4 different types of reactions. We're going to talk about each one separately. So synthesis reaction is our first one, and this is 2 or more elements or compounds combined to make a more complex substance. So we have A plus B yields, and yields is just like an equal sign, you guys, okay? It yields A, B together. So 2 elements combining to form 1 molecule or a compound. Now, decomposition is compounds break down into simpler substances. So here we have a molecule or compound, and we're breaking it down into 2 separate elements being added together. Single replacement occurs when one element replaces another one in a compound. So we have a compound and we have another element being added to it, but now we've replaced that blue with the green. Do you guys see that? The blue has been swapped with the green. Now we have a new compound, and the old element has been like shoved out to the side. It's been replaced. Double replacement occurs when different atoms in 2 different compounds trade places. So these are 2 compounds. So we have AB and then we have CD. And now we're kind of like switching partners, right? It's like a switching compounds. So the green was with the yellow, now the green's with the red. The blue is with the red, now the blue is with the yellow. So we just like swapped, and now we've made 2 new compounds out of the same elements that we once had. Now if we look at these individually, you can see synthesis. This is a real example of it, okay? Here we have carbon, and it's being added to a molecule of oxygen, which is 2 oxygens together. When we put those together, what we're going to have is CO2, carbon dioxide, and now we formed a compound. So we had an element plus a molecule, and now we're yielding a compound. So they were apart, and now they're all together, kind of like 2 plus 2 equals 4, right? So this is like the simple math problem. That's how I look at it anyway. It's just synthesis. Decomposition. Now, if you think of decomposition, just a word, decompose to like break down, right? So we're starting with a compound. So in this case, we're starting with NaCl, which is just table salt, and we're going to decompose that. So we're going to break it apart. So we end up with Cl chlorine by itself plus Na sodium by itself. So it started together and it ends apart. So this would be like 4 equals 2 plus 2. So now we're starting together and we're decomposing it and splitting it apart. Single replacement, it's called single replacement or single displacement. It can be worded either way, so just know that for a test or a quiz, you guys. In this case, we're starting with copper chloride over here. This is a compound, and we have zinc being added to it. Now, what we're doing here is we're going to replace the copper with the zinc, and you can see that over here on our product side. So we end up with zinc now being in a compound with chlorine and copper out by itself. So we successfully replaced one of the elements to form a new compound. And then double displacement, but it's really called double replacement too, and you'll probably hear it called double replacement more. So this place we have different elements or compounds or molecules, you guys, and we're going to swap them. Okay, so we're going to do like 2 things are being replaced now instead of 1, and that's why it's called double, right? So we have magnesium and oxygen as a compound, and calcium and sulfur as a compound, and now we're going to like swap partners. Okay, like if these 2 are together and these 2 are together, now we're going to just swap them. So magnesium used to be with oxygen, now oxygen went to calcium. Okay, calcium used to be with sulfur, now sulfur is with magnesium, right? So do we see how it swapped? Like the pink used to be with the blue, now it's over here with the green. And the orange used to be with the green, and now the orange is over here with the blue. So literally they just swap partners. Like if you were dancing as a couple and there's another couple dancing and you swapped and danced with the other person. That would be a really good example of double displacement. Okay, so now you have all these different examples, and it says, go ahead and figure out which one's which. Hopefully by now you could see which one is which, but number 1 is going to be your single replacement. So you can see that we've replaced the zinc, right, with the copper. And so go ahead and put that in for single replacement. And these are the ones that we just went over, you guys, but just make sure that you're putting in your answers. So number 2 is decomposition. Number 3 is the double replacement, and number 4 is a synthesis. All right, that pretty much sums up 3A. Thanks, guys. Bye.